My name is Carlos Garcia. I am the principal of Gravity Architects here in Los Angeles, California. We're introducing this rapid shelter prototype called Treehouse. This is version 2 of several. This is the one that we sort of landed on for the showcase, specifically for the kind of inland forested portion of California. A lot of the sort of facade details and treatments can be manipulated or changed based on the client, the environment. Really big on contextualizing design. So, while this design might be suited for one specific environment, we're pretty insistent on the analysis for each environment wherein these things will be implemented. I got started pretty much immediately after Hurricane Katrina in 2005 is when I was an undergrad. So after graduating in New Orleans, post-Katrina, a lot of the work was focused around disaster recovery, specifically disaster recovery post-hurricane. So a lot of the focus was on hardening and being able to withstand these sort of design criteria like wind speeds and water intrusion, windborne debris. So a lot of the sort of design cues that this thing takes are from those early sort of disaster recovery days. A lot of the sort of design cues come from the core tenets of the emergency preparedness and disaster recovery, about design for all, accessibility, speed of implementation and fabrication, and then ultimate sort of rollout. So this thing is, it meets the wide load sort of size restrictions for delivery. So it's mostly leaning toward the idea of prefabrication, or at the very least modularity. These units are built from OSB SIP, structural insulated panels. So that's where the modularity component comes from. The exterior walls, the floor system, and the roof are all built from what are called sandwich panels, which are basically expanded polystyrene foam in between two layers of OSB or oriented strand board. The advantage there is you get a lot of the structural integrity and insulated properties of those two materials together without having to sort of piecemeal construct these things. And it really helps with the sort of prefabrication aspect, because these panels are all pre-cut, pre-routed, with all of the openings, with all of the splines. So there are structural splines that sort of connect the panels together, and then routing for all of your sort of electrical conduit and things like that. A lot of the aspects of this design come from this, what was called blitz build back then, which was basically a single family and multi-family rapid turnaround for these organizations. Make It Right down in New Orleans, Louisiana, Global Green, which did much similar things, basically taking these prototypical designs, manipulating them for a specific site, a specific client, and then rolling those out CD sets in a matter of 2 months for a 2,500 square foot house. So yeah, I at the time was working for the executive architects who was hired by the Make It Right Foundation to take these sort of napkin sketches that we had received from design architects around the world, and take them from concept, schematic design, design development, through construction documents, and then CA construction. So a lot of the first leg of my career was in single and multifamily housing, sort of disaster recovery and emergency management. So I learned a lot really quickly, just because, sort of out of necessity. I think our teams were very lean back then, and trying to wrap our minds around the severity of the disaster, and then also taking on a lot of the things that are sort of architecture adjacent, but not really traditionally architecture, like communicating with clients about their needs and wants, and then also about the sort of economic aspect of this, making decisions that would fit budgets that were impossibly small, but still required the amount of adaptability and flexibility that you would want out of any other typical sort of single family or multifamily build. A lot of these materials and new companies that were sprouting up around sustainability and cradle to cradle were all very new to everyone. I think I was probably part of 45-ish, somewhere in there, over the 5 years I was on those teams.
You know, the lessons that you learn from all of that real world experience sort of influence this conceptual stage idea, which really is sort of improvement on the real world projects that you've done to date.
Yeah, so this specific unit is sort of a conflation of all of those things that I kind of just spoke about the sustainability, adaptability, accessibility, and just things cues that I've taken from other projects, things that I've learned from other projects since then, and how to improve upon those initial ideas. Like I said, a lot of these things were really new at the time, and I think we were able to build up a sort of internal knowledge base surrounding those things. But as far as like implementing them or utilizing some of these tools in other projects didn't come until much later. So this is kind of the amalgamation of all of those things, being that California, where I practice now, has much stricter regulations around accessibility and sustainability than 10 years ago in New Orleans, Louisiana. So as all of these things are sort of progressing over the lineage of the projects themselves and the work, it also, you sort of build up a repertoire of sort of different moves and materials and things that you can use in your toolbox that maybe you couldn't use in a project 5-10 years ago, but now you can. So a lot of the design features, and I'm sure we can get into more of those in detail later, but a lot of the design features that I'd sort of imagined using in these projects way back when are sort of coming into fruition now. A lot of these things are tested and proven, as opposed to just being purely conceptual as they were a decade ago. I mean, my ultimate goal was to sort of run my own boutique practice, and I think being with the firm that I was with for the past 4 years or so, I picked up a lot of the sort of business of architecture that I was hoping to pick up from that process, being a principal of a small design studio. And now moving into Gravity, when I registered the firm with the county of LA back in 2019, just looking to help out some friends and family with some small single family and multifamily residential designs that we had sort of been kicking around for a long time. And then enter COVID-19, and it sort of became my main focus, because a lot of these other sort of projects that I had going on in the background suddenly moved to the forefront and occupied the majority of my time. So I made a pivot late 2019 to early 2020, and then ultimately making a departure from the previous firm in the first month or two of 2020, and then just solely focusing on Gravity for the past, I don't know, 6 months or so. So I've been able to build up a tiny client base that I've had great experiences with some of the clients that I've been lucky enough to have over the past couple of months. And I sort of hope to continue that as my main focus for the next few years.
And what's the kind of range of projects that you're working on at the moment?
Yeah, as I mentioned, I got my career started on single family residential, multifamily residential, and then moving more into commercial work, doing a lot of mixed use projects and quite a few offices and commercial spaces. So I wanted to pivot back toward housing as much as possible, mostly because living in LA, I think it's unavoidable, this large intractable issue of the availability of affordable housing in the city. So wanting to contribute to that as much as possible. So any kind of housing project that I can really get my hands on, I definitely try to tackle. Things are built to the wide load restrictions of 18-wheeler trailer. So 1411 is the widest sort of out-to-out dimension that you could safely have traveling the just regular sort of surface streets. The length dimension, you can manipulate. This one is 28 feet, just because we're trying to make this thing as lean and compact as possible, which means a lot of the overall dimensions are constrained by the shipping dimension. So if possible, because this thing is imagined to be all sort of factory built. So the unit itself, outside of the cladding and the deck, and the roof deck, the stair, and all that stuff you see sort of outside of the envelope of the building, is intended to be built in the factory. What that means is a lot of, the site-built concerns that you might have for weather condition and the sort of inconsistency of different trades touching this thing all at once or sequentially as it happens on site. You can have a lot of very focused labor on their specialty, working in a controlled environment. So that's the benefit of factory building, and that is the reason for the out-to-out sort of size constraints of the building. What that yields is actually quite a comfortable one-bedroom apartment unit.
Does it need to be built in a factory? If you just have the SIPs delivered, could it be site built, assembled pretty simply on the site?
For the vast majority of SIP projects, whether they're OSB SIP or metal aluminum SIP, most of them are built in the field just because you're already removing a lot of the sort of build time that you would encounter for, if you were to build something like this, a stick frame, you would still have to have a framer on, you still have to have insulation, you'd still have to, be routing all the conduit and, potentially ductwork and plumbing. So sort of pre-routing all of those things, having pretty much the need for framing removed because the panels themselves, as in the name, are structural. So you're not having a separate framer come out from the sheathing person. It's all one system.
Right.
So yes, typically all of that would be done in the field. The idea is with these, if there were a case where we would have to mass produce, say, 50 of these things, having a factory floor to be able to take advantage of the repetition and the same sort of labor involved in each aspect of constructing this thing, you sort of remove the downtime of having somebody leave and come back to the site, as opposed to just having all of these things being built almost at the same time, or at least very quickly on the back of the next one, and then just having them all shipped out en masse, or at least as much as the staging area can hold until they're installed in their permanent location on site. So the idea is that, yes, while you can just sort of site build all of these things and lean on the modularity aspect of the SIP, which most SIP projects already do. So there's a lot of sort of unknowns here, and I think, at least for the SIP end of things, they've sort of built in their niche already, and they're very good at what they do. And I don't know that they necessarily want to step outside of that. Yeah. And on the other side of things, you're asking the factory floor to take on something that is somebody else's system entirely, and then having them sort of build it in their own space. So yeah, again, it's not a question of whether or not it can be done. I think it can. It's just convincing both sides that the other has a very clear delineation of responsibility and thusly liability, like where their line starts and stops. In this version, and I'll say again, like this, the unit was intended to have sort of the same bones. So we would basically have the same configuration layout, obviously dependent on the client. This is just sort of a case study for this specific type of environment. Heavily wooded. We're looking at rapid renewable materials. So none of this, or at least in this version, is planned on being built out of anything but dimensional lumber and different types of wood. So the cladding itself is this high pressure treated bamboo. It's all, Class A, fire spread rated, very high tensile strength. We're looking at this as sort of like a rain screen cladding, because again, the unit itself is pretty self-contained.
Aesthetic skin for us.
Right. That could potentially be changed per the needs of the client, or in my opinion, more specifically for the needs of the environment. So there's another group that we're working with in another state in a completely different environment, where we've discussed what is most appropriate for that specific context, and using local materials and things that would be more appropriate for that environment is something that we're working on now. So I think the sort of guts of this box are going to stay the same, and then as this thing gets moved from location to location, it sort of takes on cues from its own environment, its own context, wherever it lands. So the idea is that it becomes contextualized by its facade materials. And this one just happens to be in a heavily wooded area. It can be outfitted with any kind of metal composite material, any kind of wood material. Specifically right now, we were just looking at, rapidly renewable materials. So staying in the wood families is kind of where this design is going. But certainly it could be outfitted with any other facade material that you can think of.
What's bamboo typically? Is bamboo a very common exterior siding material right now? I guess I haven't seen.
Very common, no, not yet. But I think as far as rapidly renewable woods are concerned, and it's more of a grass than a tree, there are species of bamboo that are being worked with in sort of Indonesia, Thailand, and the sort of areas of the world where it can be grown quite quickly. It's used often as an interior wood material, but it's getting to the point now where some of these things that have been tested by the various testing laboratories are more widely usable. And I think we're going to see a pretty big uptick in the next, 3 to 5 years for exterior use as well. Even so far as to move more toward engineered wood products. Specifically for structure. There have been a couple of conversations that I've had with reps from bamboo companies that are talking about moving into the timber market, the sort of type 4. There's a new sections in IBC addressing timber construction, what used to be heavy timber, but now is laminated wood materials. That bamboo I think is going to enter into that space pretty soon. So you're going to start seeing more of it as cladding, which is sort of already exists in that world, and then more into structural materials, I think, pretty soon.
Cool. So this is also a demonstration of sort of maybe what's to come from the sustainably sourced materials.
We're imagining this as sort of switch glass, where there's electrochromic, I believe it's called, glass, where you can flip a switch and then the glass sort of floods with, well, actually, it goes the opposite way. So its natural state is actually cloudy. And then when you flip the switch, it put a charge through it, it becomes clear again. And from the roof panel down is probably 10 foot 11, 10 foot 10, which you're hitting the max at 11 feet again for just delivery. And if we're not delivering this thing, if we're not factory building it and somebody is looking at building on site, we're not at all constrained by those dimensions. Then it's just, what in this case, the IRC, or if there's a more stringent local code to cap out the maximum panel size for the OSB SIP, that would be our constraining dimension. But for delivery, we're looking at 11 feet and then the 1411 in width, which still gives us a pretty generous sort of spacious single bed layout. So yes, to answer your question, that is the full height. We're trying to give as much daylighting to the common areas. So behind that glass, you're looking at your dining area, your kitchen, your living room, to make sure that these units, while small, are maximizing the amount of daylight penetration that the unit has. So looking at either laminated glass for safety, depending on where we are in the world, because there are certain areas that require, for instance, max wind load design of 130, 140, 150 miles per hour, depending on where you are. I mean, that specifically is in the Gulf Coast, where, like I said before, we had to deal with that a lot. So things like laminated glass and tempered glass are an absolute must. Yep. And then looking at layering on these sort of different attributes of glass, like low emissivity glass, frosted glass, and things like that on top of those. So yes, I mean, you would have insulated units for any exterior walls, whatever depth of expanded polystyrene foam or in the center, which is just your kind of white foam, and then another OSB layer in the bottom. In the depth of that foam, you can run what are called splines, but they're just effectively just dimensional lumber, the same way that you would find in a floor or wall system. Really, what those are intended to do with the wall panels is to give some meat for them to kind of clamp on, because you do have an out-to-out dimensional restriction on how wide you can make these panels for shipping and for production. So when you get out to the field and you have two panels that are coplanar that sort of comprise one single long wall, you need to connect them in some way. You can't just kind of mash them together. So one will have a vertical spline, which is just a dimensional lumber piece of wood, and then the next panel sort of grabs on to that spline. So you can introduce these splines in other places, like in roofs that are pitched. You know, say you have a gable roof and you have two pieces coming up to meet each other. You can't just have the two sandwich panels come touch in the center. You need to have some kind of structural component in there to catch both of them. So when we say adding splines, we're really just talking about adding dimensional lumber framing inside of the thickness of some of these panels in order to increase the strength. Itself, I mean, if you take away all the sort of trappings of the exterior decks and the stairs and the cladding even, the unit itself is pretty well self-contained as far as waterproofing and insulation. So once you're adding these things, it really just is to the exterior. So we would probably have some what I call sleepers, basically just a thin piece of, in this case, wood that separates the finished material from the actual sandwich panel itself, because the OSB is not going to be walked upon in any way. So you'd have effectively like a raised deck above the actual structural depth of the OSB panel. So you could potentially change out the finished material if you wanted some kind of, you know, Trex decking, or if you wanted it to be natural wood, or even some kind of, I don't know, exterior tile material. We could figure out, you know, the weight, the load of the material plus the live load of the, you know, the person and furniture and everything else they want to throw up there, and size these things accordingly. So no, I don't think it's a huge leap to get there. I think we would have to know that going into the kind of schematic design phase, so that we can, you know, have this discussion with the OSB SIP manufacturer early on, so that it's, you know, kind of happening while they're designing their panels as opposed to much later. Like I said, that's, I think, where you incur most of the cost. So we can talk about the floor plan here. So as you enter off of the site-built decks, we want to maximize the amount of exterior space that these units have. You're coming in from the broad side of the unit, which, as I mentioned before, the level of adaptability here is pretty high. If we were to go to a multifamily configuration, all that we would do is be rotating that side entrance to the front of the unit, and then having some of the exterior space, probably some sort of Juliet balcony coming off of the bedroom. So you can imagine coming in from what is planned north, the top of the drawing here, entering through your sort of living, dining, kitchen area, and then your exterior space being toward the back of the unit. So the main entrance, like I said, is off of plan west now, the way that it's facing. You're coming into sort of a foyer area. Plan south, you have your bedroom and study. Plan north, you've got your living room, your dining room, and your kitchen area. We want to include as many of these spaces as sort of separate livable spaces as possible. So you're not living in a sort of studio apartment or efficiency environment. This wants to feel like it's the sort of full unit experience. So the dining area is separate from the kitchen, is separate from the living area. We've incorporated a small fireplace that, you know, that again, that's kind of a addition onto the main unit. Doesn't need to exist for the purposes of rolling out the first sort of series of these units, but it's something that we thought would be nice in an environment like we're showing this thing being built. Everything is built with California's, you know, CBC Chapter 11 accessibility, so even more stringent than the ADA, which is, you know, sort of national. This is specific to California, but we lean on this because it's much more, the regulations are much more strict. A lot of the design for accessibility is sort of baked in, and we want to make sure that, you know, if we have a client that has that's differently abled than a different client, then we're not having to completely change the design layout to try to accommodate those. But we think about them from day one, so that when we're talking about design for everyone, we actually mean that, and we want this thing to be as accessible, not just in the literal sense, but in the kind of broader sense, accessible to people like, you know, aging into their permanent living situations. This thing, the next step is to see whether or not this thing can be RVIA certified, so that this thing can live on a chassis if you decide that you want to pick up and move. You're not bound to that specific site, but this specific unit is envisioned to be a a permanent living situation right now. This is just a single unit, but as I mentioned before, if we wanted to make this a 2-bedroom unit, we could easily mirror this over the long axis and create a 2-bedroom unit with a much more generous living space, bathrooms, closets, instead of these sort of built-in arrangements you have with something that's more compact and lean, as it's shown here.
So you would go, so when you say mirror, you'd go on the wall at the headrest of the bed, like so to plan east.
Yeah, that's correct.
The
So
opening a book.
what we're sort of envisioning there is, like, if you can imagine the mirror image of this plan over that demising wall, what you would have is, you know, kind of spread out that living kitchen dining space so that it's twice the width. That bathroom then could become another bathroom. It could become bathroom plus or a powder room plus your washer dryer. And then the living room, I'm sorry, the bedroom then becomes 1 bedroom, 2 bedrooms side by side with a small corridor between them to access the second one. So it's something that's sort of built into the design. And if we can find a way to arrange these things in a multifamily configuration where instead of 1 or 2 units, it's now 20 or 30 units, the efficiency of being able to, you know, have a single unit module developed and ready to roll out, and then the adaptability of having the 2-bedroom unit as just a mirror image. So we're not having to redesign completely this thing. I mean, sure, there are going to be some minor tweaks, but the idea is that if you wanted to roll this thing out as a multi-unit building, you would have the potential to do that without much sort of reconfiguration.
What considerations do you have to keep in mind, just curious, to build to the strictest ADA compliance in California?
Floor area is a big one because, you know, a lot of, especially efficiency units, they're just designed with very tight tolerances. So we have to be a bit more generous with the floor area. So what that ends up equating to is actually much wider spaces that, you know, if you introduce natural light into some of these spaces, they actually become much more generous as a result of you complying with these sort of more stringent code requirements. So it's like, instead of battling these things where you're having to say, I'm sacrificing space, as some would say, it actually becomes quite a boon to the space and its livability, because you now, you know, like I said, the kitchen, live-in, dining area. And I'm sure you've seen apartments or maybe been inside of apartments where, you know, you take one step out of your kitchen and you're suddenly in your bathroom. What this does is it requires that you design for this circulation space as part of the core design. It's not an afterthought. It's not something we're tacking on later by saying, okay, we don't have a ramp, so we'll throw a stair lift on. This is something that is in the design from day one, so that when, you know, we decide, okay, this thing needs to be available for this person and this person and this person, we're not having to change the design to suit everybody's needs. We've designed with the sort of broadest extremes in mind, and the middle sort of sorts itself out. So you have, you know, the adaptability of you know, you roll up to the dining area in a wheelchair, that table height is going to be the exact height that you need it to without adjusting anything. And, you know, I think in a lot of cases, especially in dining areas, we have these sort of multiple heights because we think we need to, you know, please every sort of different seating position. But I think what you find is that if you just comply with what is in the code already, a lot of the other sort of seating arrangements or seating setups that you'll find are quite comfortable as well. So you don't need to go do all of these sort of extra machinations just to comply with sort of basic code restrictions. You can just, you know, do it as part of the core design. And then that way, all of these things that, you know, you would be required to do if you suddenly had to make the unit accessible, you've already covered. So yeah, I think that the design sort of speaks to that in a sense, because we're taking what would be a requirement by code and trying to back into that as luxury, as opposed to just satisfying a requirement.
So it's not flat roof. It's not a flat roof the whole way. It's just the back part is where the roof deck is. So it doesn't go across the whole
right.
surface
area. We do have space for a, I believe, 12 panel, it's either 8 or 12 panel solar array, and it's not big enough to power the entire unit. So we're relying on that for just the water heating, but the panel array is the majority of the roof, and that roof deck, like I said, accounts for maybe a quarter of the roof area. The X through that mechanical plenum there is just to house some of the mechanical equipment, because we do have an exterior condensing unit, so we are picturing having an air handling unit in the interior. Now that said, you don't really need anything as robust as that for the amount of space that this is. You could really just have something as simple as a mini split system, which is effectively just like a tiny condensing unit outside, and then having a wall cassette or ceiling cassette that's either flush mount or face mount in one of these roof or wall panels. But we're picturing something a bit more robust than that, since we have the exterior space to be able to tack on a sizable condensing unit. But it doesn't need to be outfitted that way. It's just a matter of whether or not you want to include an air handler plus your ductwork, which we have space for if we take away some of the bedroom ceiling height, which is pretty generous already. I mean, you're looking at 8 foot clear in the bedroom, and then something like 9.5 in the living areas. So it's, it looks small, but it's actually quite generous.
The vaulted ceilings in the living room and kitchen kind of give you that expansive sense of space too.
Or the advantage of coming into that sort of drop ceiling area and walking into that vaulted space is it gives you that forced perspective of coming into an 8 foot and then walking into a 9.5 foot. So you have that kind of big reveal, even though, like I said, it's a tight, compact space. But as you walk through and enter that living room area, you get this sort of volumetric change from your sort of condensed area into a much larger, expansive space. So the idea here is that everything sort of centers around that fixed piece. So you do get a little bit of privacy from your dining to your living area, while all of this happening sort of within, call it 14 feet of width. So you have a generous enough dining area next to sort of breakfast nook, overlooking what would be some outdoor seating. So that large, expansive floor to ceiling window in the front actually acts as your sort of portal to the outside. And the configuration of these things, the sighting would be very important. What we're sort of picturing is that overlooking this panoramic view of whatever kind of forested area that this specific design happens to end up in, that the units are positioned so that this sort of picture frame window ends up facing away from any other unit, so that it's not interrupted. You're not looking into your neighbor's living room, right? No, the fireplace is not structural in any way. We're just showing that as a way to break up the space a little bit, just because we want to make sure there's some degree of separation of space between the different uses, so that you don't, when you're sitting in your living room, you're not feeling like you're sitting in your kitchen, or vice versa. Or when you're eating at your dining room table, you're not looking at the couch. So there still is some division of space without the interruption of like a partition or a full wall between the two spaces. It just makes them feel much smaller than they need to be.
And this room is 14 feet wide, is that right? From the couch to the kitchen?
That's right, yeah.
Yeah, so I mean that actually is that would actually feel like a pretty big space, because that's like almost twice the width of a shipping container.
Yeah, I mean it's meant to give this sort of illusion of taking the eye beyond the walls, hence the large sort of floor to ceiling windows. I mean, try to use these as strategically as possible. They're probably one of the more sort of expensive pieces of exterior material, but it's used so frequently that it forces your eye outward, as opposed to like looking at all of the other interior walls, so that any position in which you're sitting, you can see outside of this window or the various other sort of glazed openings around you. And some of them, like I mentioned before, are sort of cladded over. So you do have the opportunity for privacy there, on top of pulling in some daylighting times of day.
The question I always ask is, given all of the unique aspects of this housing design, what would you say is the most unique?
Certainly say the adaptability. So this thing, like I said, could get cladded in any number of materials and still function essentially the same way. The primary focus is contextualizing the design. So wherever this thing lands geographically, it's going to absorb some of the either locally available cladding materials, or it could be sort of a stylistic absorption of its exterior facade treatment. So it could lean, in some places more contemporary, it could lean in other places more traditional. And I think this kind of canvas from producing a design, an interior design that's already kind of baked in, is one of the biggest advantages, I think, in my opinion, because, one, as an architect, I enjoy being able to contextualize, per site a design, but you look at this thing regionally, where we're talking about potentially, rapidly implementing a shelter in different geographic locations. You bring on, okay, now we have the responsibility of contextualizing something that might otherwise be this cookie cutter design in a place where that specific design might be wholly inappropriate for the context. So how do you contextualize that thing with it, keeping its sort of core values intact? I think the advantage of this thing, introducing the idea of facade as strictly rain screen. We're not, adhering anything directly to the exterior face, the exterior sheathing of the OSB tips. We want to make sure that this thing takes on the character of a specific site. What gets ignored is the responsibility of being able to be respectful of your context.
How this is set in the forest, it seems like the perfect kind of eco-village type of, ecotourism boutique village, and basically have the whole skin of the building reflect the material that's around it.
Right. And I think that's, at least for this version of this, Treehouse version 2 is what this one's called. And the reason it's called version 2 is because there are several other versions, and a lot of those, the characteristics of each one of those versions depends wholly on where it ends up geographically. The modularity of it, I think, is one of the strongest aspects, but also the fact that you combine the modularity of SIP, which is already sort of a modular building technology. When you receive, for instance, the shop drawings from a SIP manufacturer, what you get is actually a 3D model that is unrolled onto sheets that show you the cut patterns, where the openings are, if you have any splines, structural splines embedded within the walls, where those are located, so that the guys in the field, when they receive these things, it's really almost tilt-up construction. Now, obviously, it's more complex than that, but that's the sort of the basic rundown. So if you wrap that into the factory-built housing environment, where you have, like you're saying, other types of modules that you could potentially aggregate into a larger multifamily building, a lot of what they are doing is either type 2 or type 5 construction, where you have, you still have steel studs in the walls that you have to build one by one, or even in a panelized fashion, you still have to connect those things to your floor system, which is separate from your wall system, which is separate from the roof system. Potentially, what this could do is take the advantage of the SIP sort of pre-manufactured system, the modularity of these exterior walls, the roof, and the floor, ship those to some kind of factory-built housing floor, and have them erect these things in the factory floor, so that you're removing the kind of framing aspect of what is traditionally factory-built housing, and just relying on your building systems, your MEP trades, to come in and outfit this thing with its mechanical system, all of the plumbing, all of the electrical for conduit. So that way, by the time it arrives at the factory floor, you've removed a lot of the first couple of steps of the sort of construction process in the factory. So that's the hope. We've talked to a couple of SIP manufacturers that, there's this kind of desire for control over the final built product of this thing that the SIP manufacturers like to have, which, it's a struggle, because when you take these things to the factory floor for any kind of factory built housing warehouse, where typically they'll have framers in, they'll have the finish guys in, they'll have all the MEP guys in. There's a division of labor there, but there's an expectation that everybody you have on the factory floor is going to have something to do at some point during this process. So removing the framers from that is definitely going to have to be a conversation of how do you interface this modular building technology with something that is already sort of factory built. But it seems like there's a lot of resistance on both sides, just because they found their niche, and they like that to stop the amount of liability at where they deliver the product, and sort of nothing beyond that. So I think it's just a matter of finding the right groups who are willing to take on that extra responsibility. But everybody I've talked to so far has been pretty hesitant to toss their hat in the ring in that regard.
Why choose this system versus just starting from what's possible on the factory floor that can be built? Why not just work off of essentially the operating system that is set up on their factory floor?
The efficiency of factory built housing, regardless of all the drawbacks and inefficiencies that we have right now. I'm not thinking about right now. I'm thinking about a decade from now or 2 decades from now. With the proliferation of these kind of factory floors and potentially the OSB specifically, but all SIP fabricators, once we have a critical mass of those things, this conversation will be much less theoretical than it is right now. But because we're not at a point where there are enough locations even where you could do this, I don't think that's a hindrance. I think, yeah, it's going to delay the process a bit, but I don't think it should curb the conversation. Introducing the sort of addition of efficiency of the factory floor might help cut down the build time even further.
Carlos, thank you so much for your time. Great catching up, and yeah, let's continue the conversation.
Yeah, absolutely. Yeah, it's been great. Thank you, and thanks to the Housing Innovation Club. This has been really great.